Hey guys, this is Abhishek here and welcome to the sixth session of CCNA. Today you are going to learn how two devices are able to communicate with each other with the help of IP address. With that, I am also going to show you how to assign IP address in two devices and how to allow them to communicate with each other. So without any further delay, let's get back to the session and let's start our today's class. Visit our website www.learnavi.com or download our Android application Networking Plus to practice networking quiz, interview questions and many more. For more information, check the link in the description section below. Before starting our today's session, let's discuss about our previous class. So yesterday we have learned about different classes of IP address, right? Where I have explained you class A IP address starts from 1 to 126, class B address starts from 128 to 191, class C IP address starts from 192 to 223, class D IP address starts from 224 to 239, and class E IP address starts from 240 to 255, right? Where we only use class A, B and C. Class D and class E we do not use in a network. These two IP addresses are reserved for research, testing and for future use purposes. So these two IP addresses we are not going to use in network. If you assign these two addresses, it is not going to take by any networking device. Done. So these are the three ranges of IP address that we use in a network, that is class A, class B and class C. Where class A IP address default subnet mask is 255.0.0.0, class B default subnet mask is 255.255.0.0, class C default subnet mask is 255.255.255.0. Done. Why? Because in class A the first 8 bits are reserved for the network and 0 means host bit, right? Remaining 24 bits are reserved for the host. In class B, first 16 bits, that is this is 8, this is 8, first 16 bits are reserved for the network and the remaining 16 bits are reserved for the host. In class C, the first 24 bits are reserved for the network and the last 8 bits are reserved for the host. Okay, for this reason the default subnet masks are different in all the different classes. What do you mean by this default subnet mask? What is the use of it? Everything I am going to explain you in this video one by one. Hence everything I have already explained you in my previous video. I am continuing this session little fast, okay, so that it is not going to waste your time. Now see how we write the IP address. For example, let's start with class A. Class A IP address we write as 10.0.0.1. How do we understand whether it is a class B, class A or class D? The process is very simple. Just you have to check the first number. If the first number comes between 1 to 126, it means it is a class A. If the first number comes between 128 to 191, it means it is a class B. If the first number comes between 192 to 223, means it is class C. Got it? So this is a class A IP address where the first 8 bits, right? These all are 8 bits. See, this number is 8 bit, this is 8 bit, this is 8 bit and this is 8 bit. In class A, the first 8 bits are reserved for the network. So this particular one number is not going to change. Hence these 3 bits, 3 different blocks you are able to see, right? Only these 3 blocks are going to change in a network. For example, your IP address will start from 10.0.0.1. Next IP address will be 10.0.0.2. Again it will go to 3, 4, 5, 6 till 255. Okay, till 10.0.0.255. Once it reach 255, what is going to be next IP address? The next IP address will be here, it will become 1 and here it is becoming 0. Okay, it is 10.0.1.0. again it will become 1.1, 1.2, 3, 4. It will keep going till 255. Okay, and once it reaches 255, this address is going to become 2 sorry, this address is going to become here 2 and it is going to start from 2.0. Again it is keep going till 255. Okay, these things are going to keep continue until it reach 255.255. okay, it is 10.0.255.255. after that this number is going to change here 0, right? This number is going to become 1 and these things are going to become 0 and 0. Again there will be one time that this one is also going to convert as 255. So this address is going to keep run until it is going to reach 10.255.255.255. this is the last IP address. Got it? This number you cannot change. In class A, this number you cannot change. If you change this number, means it is going to become a completely different network. What I mean to say is, for example, here you have one PC assigned with the IP address 10.0.0.1, and here you have one more PC assigned with the IP address 10. See, you can assign with the IP address any number. Okay, any number you are able to see here you can assign. For example, you can assign 10.0.0.2, or even you can assign 10.100.100.2. any number it is going to take. Even here you can assign 200. it is going to take easily. But make sure these two devices are able to communicate now. But if you change the first number itself, instead of 10 you change it as a 11, means these two devices cannot communicate with each other. Got it? In class A, if you are assigning class A IP address on two devices, make sure the first number should be same. If you change the first number, the two devices cannot communicate. Okay, if it is same, these two number is same, means it is going to communicate. Done. Same thing if you look at class B. In class B, first 16 bits are reserved for the network, right? For example, let's write here class B address 172.16.0.1. okay, this is a class B address. In class B address, these two numbers cannot change. Okay, these two numbers are not going to change because these two bits are reserved for the network. Only host portion we are going to edit. So next IP address will be 172.16.0.23. it is keep going till 255. okay, till 0.255. once it reach 0.255, the next IP address will be 1.0, 1.2. again once it reach 255, the next IP address will be, this one will become 2, 2.0. it is going keep going till it reach 255.255. okay, the last IP address will be 172.16.255.255. this is the last IP address. okay, see, these two numbers are always same. In class B address, the first two digit you are able to see, right? This one 172.16. this number you cannot change. If you are assigning IP address in PC number 1 such as 172.16.0.1, in this PC you can assign any number such as 172.16. even 100.200, it will take easily. okay, but if you change the first these two number, right? If you change this number or this number, instead of 16 if you write here 17, or instead of 172 you write here 173, on that case these two devices cannot communicate with each other. okay, if you change any number in these two blocks, it means it is going to become a completely different network. Done. This is the main work of this one. I am telling you na, these things. Same thing if you look at class C. okay, let me erase these things. okay, let me show you here only. In class C, even here also rule is very simple. Let's write the class C example 192.168.10.1. okay, in this the first 24 bits, right? 8 plus 8 plus 8, this first 24 bits you cannot change. okay, this is going to remain same. If you change any number here, it means devices cannot communicate, and this IP address is going to last till 192.168.10.255 is going to last IP address. This number you cannot change. If you change this number, instead of 10 you make it 11, On that case, this is going to be completely different network. Got it? For example, here if you write 192.168.10.1, so here also you have to give the same range of IP address 192.168.10. Even you can give 254, it is fine, but you cannot change this number. If you put here 11, it is not going to work. If you change this number, it is not going to work. If you change this number, it is not going to work. In class C, the first three blocks you are able to see, right? Because these three blocks are reserved for the network. So these three blocks should be same. Only you can change this block. This is a host part. Got it, guys? This is a very simple concept. You should understand these things. Now I will also show you why 10.0.0.1 can only communicate with 10. After any other number. Why class B address only communicating with class B? Why class C can only communicate with class C? What is the reason behind this? How these two PC will see like which class of IP address is assigned, right? See, PC is a device, they only understand 0 and 1, right? They only understand 0 and 1. They don't know what is this number 192. Whatever this IP address you are able to see here, right? They don't know what is this addresses. They only understand 0 and 1. Okay, so the process that I'm going to show you right now, it is called ANDing process. Okay, the process that I will show you right now, it is called as ANDing process. So let's erase these things first. See, these things I have already explained you in my previous video. That is why I have done it very fast. So do not worry. Now let me explain it in detail. For example, this is PC number 1 and here I have PC number 2. Okay, these two are the devices. Both the devices are connected to each other. Here let's assign the IP address as 10.0.0.1 and this PC is assigned with the IP address 10.100.100.10. 10.100.100.10. This is the IP address of second PC. Got it? Both the devices are assigned with the same class of IP address and both the devices are also going to communicate with each other. Why? Because this is a class A IP address and in class A the first bit should be same in both the PC. Okay, here see both the PC are having first bit is 10. It means it is going to communicate with each other. Why these two devices are able to communicate with each other? What is the reason behind this? Let me explain you. So for this, just write here 10.0.0.1. As I have explained you, all of this number containing 8 bits. Okay, this 10 is a 8 bit, this 0 is also 8 bit, this 0 is also 8 bit, this one is also 8 bit. All together it is becoming 32-bit address. Okay, with the combination of 8, 0 and 1 you are getting 10. With the combination of 8, 1 and 0 you are getting 0, 0. With the combination of 0 and 1, even here also you are getting 1. Okay, so first of all let's convert this number into binary bits. Got it? See guys, these things is not a part of CCNA. Just I am sharing this information for your knowledge purpose only. Okay, just for knowledge purpose. Do not use your brain too much. Just I am explaining you for your knowledge purpose. Got it? So let's convert this number into binary bits. How to convert? As we know that this is a 8 bit, right? So what is the value of 8 bits? I have explained you in previous video, right? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6 and 2 to the power 7. These are the value of 8 bits. This is the value of first bit, this is the value of second bit, this is the value of third bit, this is the value of last bit. So we want number 10. How we will get number 10? Let's find out. See, 2 to the power 3 is equal to 8, right? 8 is the closest number to 10. If you take 2 to the power 4, it is going to become 16. So we don't want 16. We want only 8. So let's write here 1. Okay. Now 8 we need 2 more, right? So if you take 2 to the power 2, it is going to become 4. 8 plus 4 is 12. So we don't want this number because it is going to getting more than 10. So let's write here 0. The number that we want, make it 1. The number that you don't want, just write 0. 2 to the power 1 is equal to 2, right? So we want this number because 8 plus 2 is equal to 10. We have got our number. Now all the numbers just write here 0 because we don't want these numbers. Got it? 0 0 even also 0. 0 0 0 0 1 0 1 0. This is the binary bit of this 10. Now what is the binary bit of 0? See, hence it is 0 means we don't want any value, right? So all the value is going to become 0 itself. 1 2 3 4 5 6 7 8. 0 itself. Done. Even here it is 0. So we don't want any binary bit. So let's write here 0 itself. 5 6 7 8. Done. In last we want only 1, right? Here it is mentioned only 1. So 2 to the power 0 is equal to 1, right? So we only want the last digit, that is 1, and all the digit will be 0. We don't want other digits. 1 2 3 4 5 6 7. It is 8, right? 1 2 3 4 5 6 7 8. Yeah, done. Got it? This is very simple, guys. Now the next step is just also convert the your subnet mask. What is the subnet mask of this class A address? It is 255.0.0.0. Now let's convert this subnet mask into binary bits. So for 255 we want all the binary bits, right? If you calculate 2 to the power 7 plus 2 to the power 6 plus 2 to the power 5 till 2 to the power 0, then only you will get 255. So we want all the binary bits value. So let's write all of the digit as 1 1 1 1 1 1 1. Now here everything is 0 0 0. So right here 0 0 0 0 0 0 0 0. Even here also all the number are going to become 0 itself. Even here also all the number are going to become 0 itself. Done. The next step is let's find the answer. See, in ANDing process what it says, 1 and 1 is equal to 1. Okay, 1 and 1 means 1. For example, the binary bit of IP address 1 and subnet mask binary bit is also 1, means it is coming 1. If any of them is 0, for example 0 1 is 0, 1 0 is also going to 0, or 0 0 is also going to be a 0. See here, 0 1 0 0 1 0 0 1 0 0 1 0 1 1 1 0 1 0 1 1 1 0 1 0. Done. And here you can see everything as 0, right? All the numbers are 0. So right here 0 0 0 0 0 0 0. Even here also all the numbers are 0. Right here 0 0 0 0 0 0 0 0. And here all the numbers are 0, right? 1 2 3 4 5 6 7. At the end we have 1, but at the bottom we have 0. So 1 0 is again 0. So this is the ending value of this IP address 10.0.0.1. Now same thing we have to convert for this section also, this 10.100.100.10. let's convert this number as a binary bit. So right here 10.100.100.10. okay, what is the binary bit of 10? You can directly see from here, no need to calculate all the time, it is going to save our time. It is 0 0 0 0 1 0 1 0. Let's write here 0 0 0 0 1 0 1 0. Now let's find the binary bit value of 100. For 100 we want which number? If you take 2 to the power 7, it is going to come 128. We don't want 2 to the power 7. So just write here 0 first. Okay, if you take 2 to the power 6, it is coming 64, right? So we want this number. So let's write here 1. 2 to the power 5 is equal to 32. 64 plus 32. What is the value? Tell me. It is coming 96, right? So we want this number. So right here 1. Now 96, here 2 to the power 4 is equal to 16. We don't want this number. So right here 0. Again next is 2 to the power 3 is equal to 8. Again we don't want this number. Right here 0. Again here 2 to the power 2 is equal to 4, right? So we want this number because 96 plus 4 is equal to 100, right? So we want this number and we don't want these two number because we have got our result. So right here 0 and 0, it is 0 1 0, it is 0 1 1 0 0 1 0 0. Same thing here also you have to write 0 1 1 0 0 1 0 0, and at the end it is same, right? Even here also 10, so write the same number as 0 0 0 0 1 0 1 0. Got it? Now let's write the value of 255.0.0.0. It is very simple. 255 means we want all the blocks, so write all the number as 1 1 2 3 4 5 6 7 8, and in 100 even here also 0.0.0, so write all the number as 0 itself. Even here also write 0 itself, and here also write 0 itself. Done. Now let's calculate the value. Here 0 1 is 0, 0 1 is 0, 0 1 is 0, 0 1 is 0, 1 1 is 1, 0 1 is 0, 1 1 is 1, 0 1 is 0. In this section see all the numbers are 0, here also all the numbers are 0, and here also all the numbers are 0. So 0 0 it is coming 0, 1 0 is 0, 1 0 is 0, 0 0 is 0, so all the number will come 0 itself. Even here also all the number is going to come 0 itself, and even here also all the numbers are going to come 0 itself. At the end we have 1, but at the bottom we have 0, right? 1 0, again it is going to come 0. Now here if you see, you will see the magic. See both of this number, right? This number and this number are absolutely same. See, hence IP address is different. See here 10.0.0.1, and here we have mentioned 10.100.100.10. Even then also both of these number are same. See here we have 40, here also we have 40. Here the number is 1010, here also the number is 1010. Here all the numbers are 0, here also all the numbers are 0. Here all the numbers are 0, even here all the numbers are 0. Here all the numbers are 0, even here also all the numbers are 0. So if these two IP address values are same, then only two devices and then only these two devices can communicate with each other. Got it? If these two numbers are same, then only two devices can communicate with each other. If these two numbers are not same, it means the device cannot communicate with each other. See why I have told you in class A the first number should be same. This is the main reason. See, if you change the first number, for example here if you make as a 11, okay, just we have changed the first number 11.100.100.10, so we have put at 11, so you need also one bit here, right? Because 8 plus 2 is 10, we want one more number 11, so if you take this digit means 1 1 it is going to become 1. It means these two numbers are not same. Got it? These numbers are not same, so these two PC cannot communicate with each other. If you write here 11 means make sure here also you have to give 11, then only these two devices can communicate with each other. It will become 1 1, here also you will get 1. I hope the concept is clear. This is a very simple process guys. This process we call as ANDing process. This is not a part of CCNA. Okay, just for your knowledge I have shared you this information. This information you will not get anywhere. Okay, this is a very important topic. Done. Now let's go forward and let me show you how to assign IP address in two computers and how to check whether two computers are able to communicate with each other or not. So for this example we are going to take two PC from here. This is the PC number 1, and let's take one more PC and let's connect both the PC with a single cable. Done. Now let's assign the IP address. Go to desktop, go to IP configurations, and here enter the IP address. For example, I want to enter the IP address here as 10.0.0.1. If you click here, it is automatically going to detect the subnet mask. It is a class A IP address. It has taken the subnet mask as 255.0.0.0. Just close it. Let's go to second PC. Go to desktop, go to IP configuration, and here enter the IP address as 10.0.0.2. If you click here, it is automatically going to take the subnet mask. Just close it. Successfully we have assigned the IP address. Now let's see whether these two PC are able to share data or whether these two PC are able to communicate with each other or not. How to check? For this, open your PC, go to command prompt. Okay, here you have to run one very simple command. The command is ping, P-I-N-G, ping space, enter the IP address of destination. What is the IP address of destination? Means this PC IP address is 10.0.0.2 and hit enter. And as you can see guys, we are getting reply from 10.0.0.2 and here it is telling TTL, right? If you are getting this message, it means it is able to communicate with the device. Okay, if you are getting this message, it means these two devices are able to communicate with each other. Or let me show you one more example. Let's change the IP address. Okay, so instead of 10, if we change the first value as 11, let's change the first value as 11.0.0.2. Now see, this PC is assigned with the IP address 10.0.0.1 and this PC is assigned with the IP address 11.0.0.2. Are they able to communicate right now? Let's see. Now instead of 10, let's change the value as 11 and hit enter. And as here you can see guys, it is telling you request timed out. Are you able to see? It is telling you request timed out. It means these two devices are not able to communicate with each other. Why? Because this time you have changed the IP address. This first value only you have changed it. So it has become the completely different network. So this is the main problem and this is how you have to assign the IP address and this is how two devices are able to communicate with each other. I hope you have enjoyed watching this video. Then please hit the like button, and if you want to take notes, if you want to play networking quiz interview questions, then visit my website www.learnavi.com or download our Android application Networking Plus. All the important link you will get in the description section below. If you are watching this video for the first time on my channel, do subscribe to my channel right now and also hit the bell icon. Thanks for watching.